Greetings. Welcome to Calculus in the PM. I'm your host, Mr. Sandel. Today we're looking at the quotient rule, and I'm using notation that's similar to the product rule. Now this is something for the chapter test you don't have to have memorized, the product and quotient rule, but you will need it memorized, and you will have it memorized because you're going to use it often enough that you will. Okay, I'll give you a sheet for this unit because I'll test you the same way I test any regular calculus class, not different for AP. But you will need to memorize this, but don't make an effort to sit down and memorize this. Just use it often enough. Now the reason why I mention this is the product rule. What is the product rule if it's two things, f and g, being multiplied? Derivative of the first thing, second thing left alone, plus, then vice versa. First thing left alone, derivative of the second thing. Look at how this is similar, how it's different. This is derivative of the first top thing, I should say, because it's quotient, it's a division, right? Derivative of the top thing, leave the bottom thing alone, the denominator. You guys know numerator. Leave the numerator alone, derivative of the bottom, the denominator. Whatever you have on the bottom, you're just going to square it and do nothing. Like, you're going to say, I'm going to do no calculus. Well, you're doing calculus. This is the shortcut for the definition of the derivative, right? And every time you do a derivative, you're actually doing a limit, h approaching 0 for the Stokes formula, right? Okay. It's best if we just try this out. So, I'll start with B. I've circled B and D there. So let's just write this. I'm going to write this out though with color code f of g, f of x. Oh, there's that glitch in here. F of x equals, well, my numerator is 2x plus 3. The denominator is x minus 1. I'm just rewriting the problem so that you can follow, and I'll use the same color coding, right? As here. F prime is equal to. Quick question. Would it be okay if I just put this here and did the derivative over here? No. Good. Okay. Rubbish. Can't do that. Okay. Back to this. Derivative of the numerator. 2x plus 3, the derivative is 2. X minus 1, as is. Subtraction is built into the formula. Use brackets. You may make errors otherwise. Then, 2x plus 3, the derivative of the bottom is 1. So you don't need to write it down. I'm going to write it down just to show I've used this g prime thing. But now,
where did you get the x, like the x minus 1? That's just from the bottom going up.
Yep. Because g left alone. G being f being the top. Okay? So that's why I'm color coding it here. Bang, left alone. This is left alone. Okay. Then, square whatever's on the bottom. I'm going to leave it though. I'm not going to multiply it out. And as a rule, don't multiply it out. It's fine as is. Usually you want things in factored form, and this is factored. Right? Less chance for error. Now, you could group on the top. Let's do a quick thing here. So that's 2x minus 2. I'm going to drop the color scheme on the top. Minus 2x minus 3. On the bottom, x minus 1. You guys follow me? I was just distributing, right? If it says simplify, you would No, this is, the bottom is as factored as it gets, so that's simpler. Don't, typically factored form is the most simple, like if you're asked to.
You can put 2x.
If I ask for first step only, which I do sometimes, just leave it like this. Or if you had to plug in numbers into it, you might even just do it there. But what does this turn into here now?
Minus 5.
Minus 5, that's it. The 2x minus 2x is negative 5, yeah. So this definitely simplifies. Negative 5. Leave in factored form whenever possible. Okay? So it's not too bad. Okay. Now the other one. 1 over 2x plus 4. I'm just moving this over just so I got some space over here. I'll do one after another, actually, just so you know. I'll make the space like this. Okay. So, D. F of x equals 1 over, what was the denominator? 2x plus 4. Thank you. The derivative then.
Is it 0? 1 derivative?
Well, let's follow the rule, though fully, but yes. The derivative of the top, bottom left alone, subtract top left alone, derivative of the bottom, right? And then square the bottom. Okay, so like you said, I'm going to write this in as 0. Normally I would just skip it, because I know 0 times 2x plus 4 is still 0. Now, minus top left alone. I would never actually write in the 1 that I'm instructing to show you what's happening here. 2x plus 4's derivative is the number 2. Now, you guys all cool with that? Honestly, once you get some practice here, as soon as you see this constant on the top, even if there's 5 or negative 12 or pi squared, it's going to be a derivative of 0. So I would skip directly into minus 2, right? And then you've got it. This is a pretty slick, so I'd just say negative 2 over that squared, right? Now, how are we on that? Not bad, okay. Not too shabby, yeah. Oh, that was the question we went around with there. This one. Now, this is one of those ones, basically, if it was an ABCD multiple choice question, and say this was D, this is the answer. Like, the whole point to this is, do the derivative, but then you got to do enough manipulation to match this answer. Okay, so we have the answer. So I'm going to rewrite this, but when I see radicals and I want to do calculus, it's more helpful to think of it as x to the power half, right? So my first step is not to do calculus, it's to rewrite this. X to the 1/2. X to the 1/2. Minus 2. Okay, we're good with that? So now I can do calculus. Let's try this out. The derivative of the top is, bring the half down. What is it?
So it's 1 over 2 root x. 2 root x.
You're saying root x?
Yeah. On the
Oh, on the bottom. Okay, good.
It's negative 1/2.
Gotcha. I'm going to write it out, yeah, like this, and you're good. You can do that in your head, that's fine. I'm gonna write it out this way because I'm suspecting more people will probably do this in 2 steps. If you can do it, you're a sharp cookie, go ahead. Then subtract, because that's built into the formula, the other portion. Top thing left alone. And then the derivative of the bottom happens to be the same thing again. 1/2 x to the negative 1/2. The -2 part zeroes out, right? Because the derivative of -2 is 0. Okay. And you're steps ahead, I think you got it. Now, let's just think about this though. Let's distribute, squared for the bottom too. Okay. Now, distribute the top. 1/2. First of all, I should ask, is there any questions about this first step? Derivative of the top thing, bottom left alone, minus top thing left alone, derivative of the bottom. Square the bottom. Leave it. Don't do a thing to it. Hands off. Okay. I distribute now. 1/2 x to the negative 1/2 times x to the positive 1/2. Well, the half part is still going to be half, right? Number times number is half times 1. So this is still 1/2. But the x to the negative 1/2, x to the positive 1/2, what does that turn into? X to the 0. It cancels out, right? Yeah. 0. X to the 0 is 1. So that's it. It's just 1/2. Do we see why? Some do, some don't. And that's good. We will see. I'll do this as an aside. 1/2 x to the... I'll do it this way. I'll change the question first and then just see. X to the 3. If I was doing this, you would just say 1/2 x to the 8, right? Okay. Now, I'm not doing that. If I was doing this, negative 5 x to the positive 5, what would you tell me? 1/2, because this negative 5 means over x. Or cancel, or however, x to the 0. Now,
You can just multiply, there's a negative 2, 2.
hang on, you're getting ahead of us though. I know what you're saying. I'm just...
That's all you're doing.
Now I'm talking about x to the negative 1/2 times x to the positive 1/2. They cancel each other out, right? That's where you get the 1 from. It's disappearing in here. You see why it's just half now? Okay, it's that principle. Now I've got to distribute it times negative 2. Negative 2 times positive 1/2 is just negative, right? 1. So, minus x to the negative 1/2. Now, moving on. Talking about this part, right? So, minus 1/2. What happens to the x's in this case? X to the 0, so 1. Okay. We're good here, right? Okay, I am. Okay, good. Then, last, just leave this here. Okay, what does the top simplify to? The halves cancel out. Half minus a half. Right.
Negative 1 over x.
So we've got negative 1/2 as the exponent, and the negative signs. Okay. So what does negative 1/2 mean? Flip it to the bottom. What does half mean as an exponent? Square root. So, I'll do some thinking here. Negative 1 is, the negative sign still left up top, right? We can do it that way. Put the root down there. That's from the x to the negative 1/2. Then inside this square here, x to the 1/2, oh, that's root. Okay. And that should be what it is. Okay. There we go. Not too shabby. I have some questions for you. Yeah.
Is this alternate?
I think so. You guys can do that. Yeah, please do these. Seems like a reasonable assignment.
Are those the answers in like?
Yes, the answers are given, because I gave you some odds.